Today we're going to be talking about composition of functions. So if you take y equals the square root of x plus 3, there are two operations that need to be performed to do this. The first operation would be to add 3 to x. The second operation is to take the square root of the sum. The set of ordered pairs x comma y such that radical x plus 3 is the composition of two functions. So basically, the composition of functions is the combining of two functions to create a single function. There's different notation for this. The first notation is f parenthesis g parenthesis x, close the parenthesis, and that's pronounced f of g of x. But of does not mean to multiply. The second notation is f, little circle, g, close parentheses, of x. And what this little circle thing means is f following, sometimes I say after, g. F following g of x. So we're going to do some combining of some functions. So we're going to take f of x equals x plus 4 and g of x equals x squared, and we're going to combine them. Actually, we're not going to combine them yet. We're just going to find f of g of 5, which means that if they were combined, we would find what 5 is in g and then take that result and figure out what that is in f. It's a little confusing, but watch how it works. So you're going to perform the innermost function first. So in this case, it's g of 5. But in B, you're going to do f of 5 first. So it's just like what we did the other day. So we're going to start with g of 5. So I write the rule for g, which is x squared. And remember, I am taking 5 and just plugging it in for x. So I get 5 squared, or 25. So g of 5 is 25. Now, I really want f of g of 5. And if g of 5 was equal to 25, right, from this previous, I'm going to replace g of 5 with 25. So I'm really looking for f of 25. And the rule for f of f function is x plus 4. So I am now taking 25 and plugging it in for x. So I get 25 plus 4, or 29. So f of g of 5 is equal to 29. So if I were to combine them and get a formula, which we will do later, that's a little harder, I would then be able to plug that into the newly formed function and I'd get 29. Okay, on B, I'm going to do f of 5 first. So the rule for f is x plus 4. And I'm going to put the 5 into that. And I get 5 plus 4 is 9. So f of 5 is 9, the way that g of 5 was 25 over here. But what I'm looking for, secondly, is g of f of 5. And I know that f of 5 is 9. So I am going to find g of 9. I'm replacing f of 5 with what it's equal to, which is 9. And the g rule is x squared. So now I'm going to take the 9 and substitute that in for x squared. So 9 squared is 81. So g of f of 5 is 81. So if I had combined these two functions, the way I talked about the radical x plus 3 up at the top of the notes, I would have had an expression involving x. But you don't have to have that to do these. You can just go and do the inner one first, take that answer and plug it into the outer function value for x. And that would give you the answer. All right, next one. So now I'm going to change the givens. G of x is radical x, and h of x is the absolute value of x minus 2. So this h circle g, 9, that just means after or following. It's the same notation as h of g of 9, which is what we did in the previous example. So if you keep it in the current notation, you're going to do g of 9 first. If you go to the other notation, h of g of 9, you're doing g of 9 first. So g of 9, write the rule for g, which is radical x, and you're going to take that 9 and plug it in for x. So we're going to get the square root of 9, which is the principal square root, which is 3, not negative 3. Remember now, I want h of g of 9. Well, g of 9 from the previous was equal to 3. So I'm going to want to substitute g of 9 with 3, so I'm really looking for h of 3. And then the h rule is the absolute value of x minus 2. Plug in 3 there for x, and you end up with the absolute value of 1, which is just 1. So the final answer is equal to 1. I don't want that intermediate value. And some kids think you do h of 9 and g of 9, like you take and plug in 9 for h and 9 for g and do something with them, but that's not the way it works. You take one's answer and plug it into the next one. On B, we're reversing it, g after h of 9. So I'm going to say that's the same as g of h of 9. Those are the same. And I'm going to perform the innermost function first, which is h of 9. So the h rule is absolute value of x minus 2. So I get 9 minus 2, absolute value of 7, which is 7. And I would like to find g of h of 9. But h of 9 is equal to 7. So we're going to replace h of 9 with 7. So I'm really finding g of 7. The g rule is the square root of x. And I'm going to then plug 7 in for x. And so my final answer is the square root of 7. Okay? Now with coordinates, similar, not as much work. We're going to find f of 2 first. Remember, f of 2 is an x-coordinate, so what's the matching y-coordinate? 5. And then I want g of 5. So now look at what is the matching coordinate for that, and it is 1. So g of f of 2 is equal to 1. Next one, g of 3. Okay, I'll do this one in a different color. Okay, so g of 3. Okay, so right here I'm looking for the y-coordinate when x is 3 in the g function. And then I want f of that value. So now I'm going to go to the f, and I'm looking for what is the y-coordinate when the x is 3, and the y-coordinate is 7. So f of g of 3 is 7. Okay, next page. Now here's where they get a little bit harder. Find h of x when h of x equals g of f of x. Find the domain of h of x. So we're no longer going to have a number. We have the variable x. And then we're finding the domain of this newly formed function after the composition is performed. So the composition of functions is just combining functions. So we're looking for g of f of x, which forms our new function h of x. So I'm going to write out g of f of x equals. And so I'm going to start with the innermost function first. So number 1, f of x. Write the rule. And remember, like the last ones, we would take x and we'd plug it in for x. Well, we'd take a number and plug it in for x. Well, if you replace x with x, you just get x. So f of x equals 6 minus x is done. There's nothing to simplify there. So remember, step 2 was to then take and do g of f of x. Well, f of x is 6 minus x. So I'm putting that right there. And so I have g of 6 minus x. Now I need to write the rule for g, which is x squared, and then I need to take that whole thing and plug it in for x. I'm following the same rules that I did in the previous page. And then I just need to simplify that. So that's going to be 6 minus x quantity squared. So 6 minus x times 6 minus x is equal to 36 minus 6x minus 6x plus x squared. So putting that all together, I get x squared minus 12x plus 36. So g of f of x is equal to x squared minus 12x plus 36. So I combined those two functions. So now if I was asked what's like g of f of 7, I could just plug it into the combined expression. X squared, 7 squared minus 12 times 7 plus 36. All right, now the domain of h of x. So this is also equal to h of x because it said find h of x when h of x equals g of f of x. So we found g of f of x, so that's equal to h of x. The domain of that is a parabola. You don't have to worry about radicals or fractions, so that would be all real numbers. And for the range, I went to my calculator and plugged in y1 equals x squared minus 12x plus 36, and I found the minimum. So remember, we do second trace min, and then you go left, enter, using the cursor, go right of the minimum, hit enter, and then you go on the minimum and hit enter, and you should get 6, 0 for the minimum. So if we were to draw a quick little sketch of this, right here it would be 6, 0. And so the range would be y is greater than or equal to 0 because there are no y values below that x-axis. On the next one, I have the same thing. I'm looking for g of f of x. So write that out. I'm going to start with f of x again. write the rule, and then remember I'm just replacing what's next to the f in parentheses into the x. But when you replace x with x, you get x, so it's just 3x minus 5. So now what I'm going to be doing is taking that value. I've kind of run out of room on that last one, so I'm going to go down here and put number 2 below. I'm looking for g of f of x. Well, I found f of x to be 3x minus 5. So I need to replace f of x with 3x minus 5. So I'm really looking for g of 3x minus 5. So I'm going to write the rule. The rule for g of x is x squared minus 1. And then I'm going to take this whole thing here and substitute it in for x. So work up here. That's going to give me 3x minus 5 squared minus 1. So I need to again FOIL that. So 3x minus 5 and 3x minus 5 and then minus 1. So 9x squared minus 15x plus 25 minus 1. 9x squared minus 30x plus 24. So that is what g of f of x equals. So that's 9x squared minus 30x plus 24. And that whole thing is equal to h of x. So again, we have a parabola. So all reals for the domain. And again, I'm going to do y1 equals 9x squared minus 30x plus 24, and second trace, and find the min. You could also use x equals negative b over 2a, or second, and then find out what the axis of symmetry is and plug that in to find a y. Remember second trace min, I do left, right, hit left, go to the left of the min, hit enter, go to the right of the min, hit enter, go on the min, hit enter, and you get 1.6 repeating, comma, negative 1. So this picture is probably about over here a little. There's your minimum. Boom. Okay, so that point is 1.6, negative 1. So your range is all the y-coordinates that are greater than that y-coordinate of negative 1. So y is greater than or equal to negative 1. On C, I'm looking for g of f of x again. And I'm going to start with f of x, which is 3x minus 1. Replace x with x, you get 3x minus 1. Number 2, I am looking for g of f of x. And I have f of x is 3x minus 1. So I'm going to really be looking for g of 3x minus 1. Writing the rule for that, it's 1/3 x plus 1, and then I'm going to take that whole thing, plug it in for x. So I end up with here 1/3 times 3x minus 1 plus 1. Simplifying that, the 1's cancel, and I'm left with 1/3 times 3x, because these simplify to 0. And then 1/3 times 3 is equal to 1x, or just x. So g of f of x is equal to x. Okay, so when we are considering the domain of h of x, which this is equal to. We also need to consider the domains of f and g, and if any of them are limited, then h's domain has to be limited. But they're all reals, and so is this one all reals. So we get all reals. We have oblique lines. So it's all reals for the domain and all reals for the range. If we graph h of x, y equals x, oops, it's going through the origin. Try that again. There we go. And that